kind of exhausting.
Well, I think we're working now. We'll go live in 30 seconds. So. Starting over. that was an adventure.
I wouldn't call it that.
Check your. Can you check the audio, Eric, on the screen while I go live? All right, we are live.
Oh
What's
shit!
up, everybody?
Yeah, Periscope.
Okay. All right, second time. Second time's the charm. Got the audio figured out. I plugged the didgeridoo in the didgeridoo dodge. That's what happened. Everybody knows that.
Sick.
Okay. So, starting over again, we're talking about reentrancy attacks today. And as John May was describing earlier, we are going to be talking about asynchronous code. Yeah, dude, we got some people chatting us up saying second time is indeed a charm, so word H encoder, I'm with you. I'm with Superposition and John May. My name is Adam Manka, and we are going to be talking about the reentrancy attacks. As I mentioned, has to do with asynchronous calls. John May, the floor is yours. You can show us your screen. You can talk about a little bit of something, but what exactly is a reentrancy attack? Can you break that down for us again?
Sure. Let's bring up my screen. So, reentrancy is when code can be interrupted in the middle of its execution and called again, essentially. That's a paraphrase of the most general definition of it.
Okay.
So in Solidity, that means a function can be called before all of its logical constraints have been fulfilled. So in the process of a Solidity function, different variables will be set, and those variables will restrict the logic, or supposed to restrict the logic, of the function to doing certain things, such as only allowing you to withdraw your money once. So in a reentrancy attack, you can call it again and again before those logical constraints are set to withdraw multiple times. And this has happened many times, but I'm going to be demoing a very simple example.
Great.
So where to start? So I have a bare bones truffle project set up here.
Yeah, zoom in on that. We can't see it at all.
In this folder, live code. So it's gonna look like that.
More.
A little bit more. Oh yeah.
There you go.
Okay, let me pull myself off because my fat head's getting in the way.
And so we're gonna have three contracts: attacker, or two contracts: attacker and victim. Migrations is a default truffle helper.
Okay.
So the victim, and we're gonna have a very simple. The victim is gonna be a very simple withdrawal function that that's gonna have a serious security vulnerability. Attacker is going to exploit that vulnerability. So you can think of victim as a small part of a much bigger contract, which has balances and a withdrawal function. So when I open this up in the Visual Studio Code, and so here we have the very basic outline of the very basic beginning of the contract. We have the compiler declaration and then the contract declaration. So we're going to have a uint, which is going to represent the balance you might have in this theoretical contract. And this balance could be, for example, the balance of tokens. And then we're going to have a withdrawal function.
And just kind of like, so drawing over and over again, right? Is that an unlimited amount of times, or is it just as many times as they have like gas in
It's
the wallet?
always going to be limited
Okay.
because there's always a gas limit. So
Okay.
remember, there's a gas limit of 6 million for anything that happens, but the gas limit for any kind of reentrancy attack is substantially lower.
Okay.
So you can never withdraw an endless amount of times.
I
But
see.
so this is gonna be our very, very flawed withdrawal function. We're gonna have a require statement that says your balance is more than zero, or balance is more than zero.
Can you zoom in on that?
Sure.
Everybody watching on Twitch, sorry about that delay earlier. I appreciate you joining up again. We just had to fix that audio thing. But do remember to please give us a follow. I saw somebody did follow us, so that's pretty awesome. Thank you very much for your patience.
And so in a hypothetical situation, your balance is going to be equal to your balance of 100 in whatever currency you like is going to be equal to a transfer amount of 1 ether, where this defines ether, of course. And so what's going to happen is when you call withdraw, it's going to use the environment variable of message.sender, which is who's ever calling it, and it's going to use a function called call, and that with the option value, and then transfer amount, and then blank parentheses. And this blank parentheses is where a gas value can be specified, so that when this transfer amount is sent to another contract, the receiving contract will have a certain amount of gas to initiate a receiver function, otherwise known as a fallback function. By leaving this blank, that amount of gas is unspecified.
See. Okay.
Which is essential to this attack. So after this is called, we're going to put some naive logic, which is going to set your balance to 0. So you see what happens here? You start with a balance of 100. Once you transfer your balance goes to 0.
Sure.
So naive coder would think, oh, well, you can't call that again because your balance is 0 afterwards. But that ignores the asynchronous nature of message.call or .call.value. So we need one more thing in this simple contract, which is overriding what's called the anonymous function. And when we do this is the function that occurs when we send this contract ether. Because to do this attack, we first need to send ether that we can drain from it. And so by making it payable, it gives the ability for us to send ether to this contract. Otherwise, we would get a VM exception. So now let's move on to the attacker contract. So we start off as always with the compiler version.
Okay. Has there been any famous cases of this happening in reentrancy on somebody that we know of? Should I look that up?
That's a thing to look up. I'm sure there has. I can't think of any.
I think the most famous one was the DAO hack, the one Ethereum Classic and Ethereum.
That was a reentrancy attack?
That was a reentrancy attack.
That's legit. So they basically...
The most historical case of what this attack is that it was a form of that.
Wow, I did not know that. Now I do. But anyways, this is...
Yeah, check that out while that's happening, because it's definitely something to talk about. It's pretty heavy.
Here it is, explaining the DAO hack. exploit. I'm pulling it up right now. Yeah, so
Yeah, back in
hold
the
on.
olden days of Solidity, when things like that were durable. I mean, some very smart people were the first people to think of this. So what we did here was we import the ABI for victim.sol.
Okay.
By importing it, we can create an instance. We can access all the functions from the address of victim. So we're creating our attacker contract. And now we're going to create a constructor for it, which is going to instantiate, which is going to take an address we're going to call A, and we're going to create we're going to create a victim variable called V, and then we're going to set V equals victim at A. So this gives us access to the victim contract. But of course we need an S in constructor. So now the essential part of our reentrancy attack is going to be our default function or our anonymous function, which is what can be activated whenever we get ether.
Okay.
First, we're going to create an event, so to allow us to see what's actually to better see what's actually happening, which is going to log this function. We're going to call it log fallback. It's going to take a uint c, which is going to be defined as our counter, which is going to record the number of times we're reentrant into this function, and it's going to create the uint, which is the balance or the amount we call each time from the function. So heading back to our fallback function.
Mm-hmm.
So this is going to be called each time we receive ether. So we're going to first increment the count. And this count's essential because, as I mentioned, even though I don't specify the gas, there's still a limited amount in victim. In
So,
victim, when you call withdraw, even though we can call it many times, we can't call an infinite number of times. So we have to have a limit.
okay. So,
So we're gonna limit the count. We're gonna limit this to 10 counts. So 10 withdrawals in one,
so
or
for
10
those,
ether instead of one.
so for those just kind of tuning in right now, essentially what he's saying is that like we're specifying the number of times we're going to withdraw post contract execution, correct?
Yeah.
Okay.
So so each time this contract receives ETH, we're going to emit the log, an instance of the log fallback event, so we can see what's happening with count and our message.value. So each time we're going to have the number of times it's been called and the value it's getting.
Okay.
And then so while count is less than 10, we're going to call v dot withdraw, or better yet, if. Let's go to some tabs, make it look a little bit better. And so we see the logic here. This will happen. This will receive ether 10 times. So when it receives the ether, increments the count. Calls withdraw, receives ether, increments the count until count is equal to 10. And then it will stop. So how do we initiate this? we create another function called attack, which is simply going to call v.withdraw. And we are there.
Okay.
So this is in contracts all you need for a very basic reentrancy attack. So we gotta let's save our changes. Make sure we haven't missed any semicolons, which is the bane of existence of Solidity programming. If you miss a single semicolon, your code will fail to compile.
There you go. It's a very, very picky language, right?
Yeah.
Okay.
Oh wow.
Solidity compiler does not like a lot of things. So now we have to deploy these contracts. We're gonna have to open a higher folder actually, because right now we have we're gonna have to open migrations. I guess we're gonna have to be able to see a migrations folder. Interesting. That's interesting. It's not. So we're creating a new file called deploy contracts.js. And so this is part of the truffle framework where we can migrate these contracts to the Java virtual machine where we'll be instantiating the reentrancy attack.
Okay.
Okay.
Yeah, I'm checking it out on the live stream. Looking really good.
That's good. It's good news. We got it right. like Ancient Coder said, second time is the try, man. You know, sometimes you can't get it
Yeah, I'm
perfect.
checking it out on the live stream. Looking really good.
That's good. It's good news. Hear that go?
Yeah, there's an echo.
Mhm.
I didn't want to cut that out. I think it's the perfect amount of echo because I think you're playing it from another.
Mhm.
So here we're using, I guess, a function called artifacts to upload the bytecode. And now we're gonna.
Oh wow.
Artifacts calls in on the bytecode you said, so it basically turns it into computer speed.
Yeah.
All right.
Yeah.
You can buy tokens. You can buy tokens in Periscope. Did you know that?
I did not know that. Really?
Yeah. Yeah, and you can get tips.
That's pretty cool.
Yeah.
So everybody hopping in, on the live stream here, definitely consider, giving us a follow. We're going to be doing a lot more, different stuff about cryptocurrency, decentralized.
So right now,
tech.
we're exporting the deployer function. So Truffle has a built-in deployer function which first instantiates the bytecode and then uploads it to our virtual blockchain.
Yeah, that's something that I always like when I first started using Truffle that I was like, what is this tool actually doing? And now I was like, oh, it's doing all of the stuff that we would have had to do by hand.
Yeah, and that stuff gets pretty complex. For a future live stream, I can demonstrate some of that stuff. But this is much, much easier. So here what we're doing is we're first deploying the victim. And that gives us a JavaScript object of all the properties of the newly deployed contract, including its bytecode and its address. And then we're using a JavaScript promise on this asynchronous call to pass the new address to this attacker contract. So we can deploy the attacker contract with the victim address in the constructor.
Whole Nurse joining.
What?
Thanks for coming on in. Whole Nurse coming in on the
Hey,
on Periscope. What's up?
shout out.
Shout out to Vladley.
And so this should be it. So let's.
Yo, if anybody has any questions live too, we'll do the best we can to answer them. We have collective experience here. And
Experience of a shoe.
collective experience of a shoe. No, we're trying to answer anybody has any questions live too. Yo, dude, you gotta cut that off.
So you think I should do this in full screen terminal? I think that's probably the move.
And,
I think that's good right there. No, that's fine. I kind of like it in VS Code for that reason, just because it keeps everything in one space, you know.
Yeah, it's just kind of small.
Yeah, I think we'll tweak it. With the other, you could go to full screen terminal. I mean, I don't care. It's cool.
Okay, we gotta change one little thing.
What's that?
Variable misspelling.
Ah.
We got Endosi Apolita on Periscope. What's up?
Shout out.
Shout it out.
We got like about 8 on Twitch. Anybody who's in Twitch, definitely say hi. I know each coder's in there. A couple other people.
Yeah, who isn't? Yeah, if you give us a shout out. Come to the Discord channel.
Join us up. Links right there.
Oh, we got getting some hearts, getting some love. And we got no audio.
We got no audio?
What?
All right, good. No, that's fine.
I can
What?
hear you.
We got audio. I haven't played with anything. I didn't break anything this time.
All right, good. What are we doing here? Are we doing migrate reset? We're doing some live troubleshooting.
We got broken.
Variable.
Is that a comma instead of a period?
No, that is just I typed the variable name wrong.
Oh, okay.
There we go.
There it is.
Whoa.
Attacker. Oh, that's very simple. Yeah, VS Code is failing me right now.
Yo, and Vim.
And Dosi giving us a lot of love on Periscope. 33 hearts, thanks. We got what is it? Stods Adagree? What's up? Just adding up on Twitch. What's going on? Give you a follow.
Reference error is not interesting.
Aaron counter to
Attacker.soul. Oh, attack. Not
we're getting some hearts up in chat. Thanks.
Real simple stuff here.
Yo, if you follow on Twitch, it's gonna do something awesome. By the way, I just set that up. I love it.
Okay, we're in there.
We in there like swimwear?
We should be. Cause now we have some deployed contracts.
All right. What exactly are you running right now to deploy that? Are you on like a private test net, or are you on?
This is the local private test net of the Truffle framework.
Oh, very good. Is that Ganache?
A version of it.
Or is it? What is it?
Well, it probably is Ganache, but they don't say it's Ganache. It's just part of when you instantiate a Truffle project. If you hit Truffle Dev, it gives you a private testnet with 10 accounts.
Yeah. So
above here it lists, so you have accounts 0 through 10 and all the private keys to play with.
Wow. That's real cool.
So here we're gonna create
It looks kind of perfect the way that like where Adam's head is. It's like perfect because it's that spot where there's no code. VS Code.
Yeah. Pick the right spot. Back the right horse in this location over here, I'm telling you. It's pretty good. I used to be on that side, but then the ForkedBlock thing got in the way.
So here what we're doing is using some asynchronous promises to instantiate the contract instances.
Yeah, ever since I learned about JavaScript promises, I'm just not sure how it was done before. Like when
It wasn't.
Like, it wasn't.
JavaScript was just designed to like animate like the simple, I guess, like GIF type things they had in the 90s. Okay, what to do now? Oh yeah, we gotta send the victim some ETH to reentrancy to do our attack. So we're gonna
do. I can't say that. Do to.
So we're using a very simple Web3 command called send transaction.
You're gonna do a full send.
Yeah,
Full
we're doing a
send?
full send.
Full send.
And
So full send.
So we're using from our web3.eth.account.
Hey, thanks for the follow. Zelda Kingman.
Who's that? Zelda Kingsman.
Hey,
what up?
what up?
0.
That's actually mad cool.
Yeah, man, we got all kinds of motion graphics going on. Welcome.
Mojo.
Anybody who's coding got any questions, about crypto, centralized technology? I do Angular. Eric's does a lot of Python. And John May's just a genius, so.
John May floats while coding.
Yeah, John.
You're not actually looking at a computer screen. We just actually like got Discord to work with his brain, and now it's just straight up. He has a copy of VS Code running on it.
Wait, if anybody's got any call at Razer, we're trying to get him a Razer laptop. I've been reaching out to him. If anybody's got any pull over there, let us know.
Okay.
Yeah, if, on that fact, this has got all of us a Razer because
I
that's
got
what
one.
I'm saying.
I love it.
Yeah, that's it.
Razer's legit,
So-
dude. It's like the MacBook of the PC. It's great.
Oh, success.
There we
So
go.
now we just
Well, that
just
was
sent
pretty hardcore. So what'd you do here?
we sent 11 ether from accounts 0 to the victim address with and we use the nifty tool web3.2y. And so what this does
No way.
is it makes it very easy.
Calculate gas.
This calculates how many y is equal to 11 ETH. So instead of typing this, you get to type that.
And Y is the smallest unit of ether, correct?
What?
Y is the smallest
Yeah,
unit of ether.
Yep, there's 10 to the 18y in ETH.
Cool. Yeah, so we're about to now attack, correct? All right.
Yeah, and hopefully this shouldn't fail. But
So this is how the DAO lost all its ether. Everybody that's watching, literally calling her.
I don't think it lost all of its ether,
Well,
but it lost a good chunk.
Yeah, a fair amount.
I like how we have like porn bots.
oh, and we got success.
On Periscope, you're talking about?
Yeah, Periscope's got mad porn bots.
Whoa.
They're just sending you hearts, John.
Yeah, they love you.
They're just like trickling in some hearts.
But all the sexy milfs.
Dude.
Yeah, well, I think they have some accounts like that. What is this one girl's name? Her name is Dipore Foxist. I'm like, if that doesn't sound like a generated name, I don't know what is.
Might not be. You don't know that. Maybe she just digs programming though.
Okay.
Yeah.
Yeah, totally. All right.
So let's look at the anatomy of what we get. We get a basic transaction receipt with this is a transaction hash to uniquely identify So let's look at the anatomy of what we get. Here in my echo.
Yeah, no,
Yeah,
no,
that's because he's playing the video.
No, I tried to
Okay.
reload something because it died on me.
Okay.
Should
Bit
be good.
distracting. So we get a transaction hash, the block number, the gas used. So in our 10 calls, we use 238,000 gas. So
That's not too
really,
bad.
that's not too bad at all. We could technically use almost 30 times as much. So technically, we could do 300 transactions.
With that amount, yeah.
Yeah, so that would be 300 ETH. It's a bit more. And then we get our logs. So see here we have 10 different logs, because a log is the basic form of what an event creates. So we have the event log fallback, the log index, and we have 10 of them. And so the progression of our function works accurately. Going back to the attacker, we receive every time we received ETH, we logged our fallback. Ten times. So let's look at our web3.eth get balance attacker address. Let's see what we have here. And so it looks like we have 10 ETH. So we're doing pretty good right now. What is 10 ETH worth? Is it about $3,000?
Yeah, sick. Let me get.
And that's how you do a reentrancy attack. Let's see how the victim's doing. And they have 1 ETH.
Fool got robbed.
Ooh.
He got robbed. He got He got fleeced, Eric. Fleeced.
Dang.
Oh
That's
man,
pretty it's pretty sick actually.
Easy way to lose all of your money by writing bad smart contracts.
Yeah, so here's a fun venture. Go to ETHScan and pour through thousands of contracts and find one that has
A bad.
and you call that value.transfer.
Yeah, we should build an AI bot that finds bad.
Searches the blockchain for bad contract.
Yeah.
I don't know how many exist, but there must be some that people have not found yet.
Well, to me, I think that since people are bad programmers in general, that kind of stuff will just pop up again, even if stuff like this is out there.
Yeah, I mean,
someone will get onto the wrong Stack Exchange forum and see this example.
Yeah.
There are reasons you would actually have to use this, though.
Sure, but then you would have like other conditions.
Yeah, if you were to do, for example, this, the balance would be 0 when you try and call it again. So when you go back into the function, this require statement would be activated. And it would fail.
So,
or you could limit your gas, for instance. You could do 2,300, and that would be enough for maybe one call, and it would fail.
Oh.
Or you can use message.transfer. This is generally the preferred way to do this.
The attack? Or the... Oh, you're talking about prevent it. I see.
Yeah, for actually, if you're actually writing a smart contract, you want to do this. Because this both limits your the gas that can go to this function here. So this function here has a limited amount of gas to do things. So when it tries to call withdraw, it just doesn't. It will not have enough gas to be able to make this function happen again. and it also throws on failure. So if somehow it doesn't happen, the entire thing will be, every variable will go back to their default.
I wonder
Maybe,
how much money in total has been lost due to reentrancy. Like ether amount. Because so Solidity isn't the only one that you're going to be able to perform a reentrancy attack on. So you're going to be able to pull it on different types of basically 2.0 blockchains. Anything with like a smart contract code where you would do something like this, it would probably be suitable.
Theoretically, anything that has this type of functionality. Now, on other smart contract languages, it's probably a bit trickier.
Okay.
Maybe not. Maybe it's easier.
I don't know. We have to test it out.
Yeah, we have to look at reentrancy and some other languages.
Yeah, is there anything that you're looking at right now that you're interested in programming in?
Me?
Zap downward.
Yeah, it seems to be. Yeah.
Yeah, Zap. Like, I mean, I would like to get one running. I would love to get an Oracle running. That'd be really cool.
We should definitely try to do that. I want to get them on the show.
Yeah. I want any type of Oracle. I really don't mind. Like, whatever type of Oracle anybody would work with. Like, if there's like, is there any other Oracles in Zap? There's got to be.
Yeah, there's a lot. One of the biggest ones is Oracleize it.
Oracle Wise.
Yeah, Oracle is a big pattern. It's been there. Like, I actually learned about oracles last July, or we could build our own oracle. That would be a cool workshop.
Yeah, I'd like to do that.
Is there anybody that so? Does Augur run with oracles to make its predictions?
Augur?
Yeah, I don't know much about how it works.
Yeah, I've never used the platform, so I don't know how it gets its data.
What is Augur?
It's a prediction market. So, like, if you're like, there's going to be, let's just use corn as an example. Somebody bets that the corn production is going to be X or, Y, you can predict it. And then somebody take a counter bet. For instance, like Conor McGregor winning or versus, could be more Nurmagomedov. Yeah, I can't remember.
So, okay. Prediction markets. Have you heard of Gnosis?
Like actual, dude, we're talking about like actual corn. You could like literally set up a bet on Augur and like put a bet over like corn production, like in like next year. You could say there could be like 20 metric tons. I don't like wait. There's probably way more than that, but I'm just saying like you could bet on the production of metric tons of corn or something, whatever you want. Like, really, anything that could be predicted. Augur's really goal is to bet on it. So there's like like for instance, somebody might put up like, will the president be impeached or like something like that. Like they would literally take a bet on that or like something like that. You can check it out. There's all kinds of bets on Augur. They have I don't know if they're live. That's a great question. I haven't really paid attention to Augur, but it's pretty cool. Yeah, but Zelda Kingman was asking you, like, actual corn or corn? Yeah, no, we're talking actual corn.
Yo, get him in the chat.
Yeah, he's talking to me on Twitch right now, man. He's asking us questions.
Twitch chat?
Yeah,
Okay.
Yeah.
Do you want to go back to your screen? Because I think we're done with reentrancy for the moment.
Augur, you have to have MetaMask, I think. Yeah, I think you're right. I actually do have MetaMask.
You have to have MetaMask, but what does that mean?
I'm going to show you guys something. Can I show you one of my guilty pleasures of a project?
No.
Yes, you're going to see it. Let me make sure my MetaMask. You're going to have to see it. Why isn't it loading? Why is MetaMask not working? Because it's not the greatest? Dude, the beta of MetaMask is pretty sick. But I'm pulling it up right now, guys. I'm gonna show you one of my favorite projects.
What is
And
it?
Has anyone used MetaMask Mobile?
No.
I'm not.
Apparently, you get it on your phone.
You wanna see how
Which
much?
that seems like the ideal way.
That seems like a plus.
Like
Oh,
you don't need a separate app to waste your hard drives.
Okay,
Wait, there's
so
another app, you say? Or is it
No.
on like Google Chrome?
It's on your browser, but in your phone.
this is what I'm talking about right here. My favorite one right here. This is my favorite point.
What is this?
Oh, you know what it is. You know what time it is.
Are we talking about C-Coin?
No, that's my other favorite
Oh.
project. That's,
I thought that was my favorite project. I want to tokenize buried treasure.
yeah. Oh my God, can I get the C-Coin book out? I got it handy. Gambling Quest. My favorite ICO
Dap
of
Quest.
all time. So this is foam. Foam is fire. Okay. You can so they're doing a proof of location protocol, and it's an ERC20 token, but it's like basically could wouldn't replace GPS, but it has the ability to like real time track stuff. So check this out. They have probably one of the best dev teams. It's like out there. Well, they did. I don't know what it is now. When I was working with them, at least. Hold on.
They really need to set up their decentralized location system.
Okay, so let's just fire up
The whole
that
thing?
box.
Yeah, it doesn't exist yet.
Yeah, it's a big issue. I think like it's pretty. XYO supposedly was like trying to do some stuff with things, but they are not really all that in a bag of potato chips from what I understand. Let me see here. Let's see, but like you can actually see this arc is basically, I believe, calculating the distance. When you see an arc fire up, which is these red lines here, it's detecting the distance between the bots. These are all virtualized, so this is just like one really cool supposed like, you know, theoretical test network. But you can actually drop stuff here. So I can be like, right here, we can be like, my beacon name is ForkedBlock, son. Okay. We're going to assign that and deploy a beacon. So really, you would use these beacons to be able to communicate distance. And let's just see. Now we can search the phone network that should have did the transaction. There it is. We got deployed. Let's research that. Right there. Bam. So you deploy like a beacon, and you would use. I don't know the best way to explain this. I haven't tried to articulate it. It's just a really cool project. It's like basically you're telling the distance between two beacons. There's thousands of location beacons all over the world, right? So you're going to be able to measure the distance between two different beacons by pinging them. Let's see what we got going on here. I don't think I have any drop frames, guys. I think it might be coming from the connection. Are you there?
Yeah, we're here.
Yeah, my connection is actually good for once. I'm kind of amazed. I'm not good, but
Amazing.
How are we doing on Twitch?
I mean, I'm
Yeah,
still
we're doing good.
a fourth of the speed Comcast promises, but
Yeah,
that's good for me. Like,
I think we got choppy there for a second. Hopefully we're back up, guys. I closed out that. I think it was sucking up a lot of memory.
What, live streaming?
No. Phone protocol. My browser. We have maxed
yeah,
out.
what were the
It was just
blue-
mining. It was mining Monero and your browsers.
Yeah, dude, they had that Monero
So,
thing going.
what was the blue like I guess circles? They
Yeah,
actually
so
have
yeah, those are
the
the
radio
actual.
system working?
those are the actual beacons. I think they're simulating them, what they would look like.
Okay.
So I'm not sure how they have it implemented. I read their white paper a while back, and if I was talking, about it, I'm not the professional on this topic. I know Ryan Fisher is over there. He's one of the main guys, and then they have a pretty solid team. But yeah, I mean, it's definitely one of my. I think it's like really cool, particularly like if you think about something like like mesh networks or subways. I think like these things, these decentralized this decentralized mesh networks, these location networks, those are going to be huge for blockchain. I don't think they're going to necessarily be as economically feasible as like a straight GPS. But if you think of something like a decentralized Uber where you're paying fees, and you might use something like the foam network or different types of games that are decentralized, which could be really cool. There's a lot of different applications for it. So it's pretty interesting stuff, and that's why I like it. I'm actually gonna roll in our ad real quick. So real quick, I wanna hype an event we got coming up. We do need signups if you're in the Raleigh area. I'm gonna roll in this ad. It's October 27th. We're having a hackathon. We're gonna do a little bit of a workshop. We got some really awesome sponsors we're about to announce for it, so that's pretty exciting. And then
a little bit of a workshop. We're going to be laying down some heavy knowledge.
Yeah, if you want to become, a basic blockchain programmer and learn the inner workings of the blockchain and network a little bit, say hi, whatever you want to do, come to this, and we'll be more than happy to have you. But I'm going to show you guys a little hype video that I'm in. And we're back. So definitely, consider that. Consider joining the Discord. Consider definitely hitting the notification buttons, the subscribe buttons, the follow buttons. Are you going to live stream that? Yeah, Zelda Kingman, we are. We're also going to throw a hackathon also on November 15th, which is going to be in Austin. And then we have one on the 29th in Denver. 29th
yes,
in Denver. And also the biggest one that we're going to be having is going to be in San Francisco on the 24th of January. That should be pretty big. So if you're around any of those locations, you can sign up for those as well. We just reopened the tickets for that. I had blocked them off for a second, but it should be fun. I mean, definitely show some love to one of our sponsors right here, Bitcoin Energy as well. You can check them out at bitcoinenergy.com. We're big fans of that. What else we got, Eric? What else you got for me?
Well, we're also, if you want to bring the hackathon to your town, don't even think twice about sending us a message, because I think right now we have a couple of talks. We're trying to get one in Vermont.
Oh.
Nothing's solidified yet, and I don't think you mentioned that we have one in San Francisco.
Yeah, I did. 24th of January. It's our biggest one.
Oh, okay, never mind. Okay, okay.
Register for that, guys. If anybody knows anybody in San Francisco, send it out. Just search for ForkedBlock on Eventbrite. They're all going to pop up in those cities. So, you want to come out, you want to meet, the crew, you want to learn a little bit about blockchain development, maybe a little bit more. You can always come out and visit us at the hackathons. We are going to live stream them for sure. Hopefully we'll have the audio right the first time we go around. But it should be awesome. So everybody who's joining in, definitely, like I mentioned, subscribe, show some love, and if you're interested in blockchain or anything, join the Discord. Right there, we're always in it. We live on Discord. We program all the time. We break things, and it should be fun. And if you guys want to come on the live stream, you're more than welcome to. It looks like we got 8 on Periscope. Wow. And to all the people watching on Twitch, we got 6. Not bad. Facebook, we got a couple. Man, that's got to be the most successful one we've had yet, for the most part. And YouTube.
John, do you think we got any more along this vein? Any type of more like vulnerability or infosec type deals?
Yeah. Next week I'm going to cover integer overflow and underflow errors attacks.
Yeah,
All
so
right, that sounds bomb.
we're
So you
gonna
got to see why you have to be careful with your numbers in Solidity.
Yeah, actually, that's something that really like made me mad when I first started learning Solidity. But it's like there's so many different ways of type def that I was like, man, I could
yeah,
really mess this up.
we're gonna show you.
I think
Huh?
Andy had to create Andy, the guy from my other side project, Texel. He had to like create an entire trigger library for trigonometry.
What?
Yeah, there's no trig value. There's no trig functions in
Yeah,
Solidity. So
there's no exponents. You have to do it all, and you have to do some crazy maneuvering to get numbers to work.
Let's see if we can start the Zap mono repo just while I'm live. Oh, broke it.
Wait. Say again. What's cut?
Yep. All right, everybody. So I'll see you later. Stay tuned next week for more reentrancy attacks or not reentrancy, infosec stuff about blockchain. And we're excited to keep producing. We're going to try and put out one video a week. I know Simon's going to be on tomorrow, probably talking about the Tether situation. We have some interviews lined up as well. Stay tuned in your area. Once again, Austin, Denver. We have San Francisco and Raleigh coming up on the 27th, which is our most near one. Check us out on ForkedBlock.com, and I'll see you guys later. Peace out.
Peace.
Peace.